Deep beneath the surface of the Earth, locked inside rock layers that formed tens of millions of years before humans ever existed, scientists have found something profoundly unsettling. Not fossils, not bones, not ancient tools or ruins. They've found chemistry. Microscopic spheres of exotic metals scattered across the planet in a global pattern so precise it mirrors the fallout signature of modern nuclear detonations. These particles appear in sediment layers dated to 65 million years ago and earlier, long before cities, long before industry, long before humans. According to everything we believe about history, these materials should not be there. For centuries, humanity has assumed a simple narrative. We are the first technological species on Earth, the first to burn fossil fuels, the first to reshape the atmosphere, the first to split atoms, melt metals, and leave permanent scars in the planet's geology. But the planet itself may be telling a different story. What if Earth has hosted advanced civilizations before us? What if time erased their cities, their machines, and their bones, but not their industrial fingerprints? And what if we've been misreading those fingerprints as natural phenomena simply because we never imagined they could belong to anyone else? To understand how this question even became possible, we have to rewind to a discovery that changed geology forever. In 1980, a geologist studying limestone formations in Italy noticed something strange. A razor-thin layer of clay separated two massive rock systems, one representing the age of dinosaurs, the other the world that came after. Embedded in that clay was an element almost non-existent in Earth's crust: iridium. The concentration was more than 30 times higher than normal. Iridium is rare on Earth's surface, but abundant in asteroids. The implication was unavoidable. A massive object from space had struck the planet, throwing dust and metal into the atmosphere and altering life on Earth forever. This discovery became the smoking gun for the asteroid impact that ended the reign of the dinosaurs. But it also did something else, something far more disturbing. It proved that Earth preserves evidence. One violent day, one cosmic collision, 65 million years later, its chemical signature remained intact. That realization triggered a dangerous question. If a single catastrophic event could leave such a clear fingerprint after tens of millions of years, what would an industrial civilization leave behind? Cities collapse, steel rusts, concrete crumbles, bones decay, even monuments erode into dust. But chemistry doesn't forget. Energy use alters isotope ratios. Industrial processes create synthetic compounds. Nuclear reactions leave unmistakable signatures that persist for geological timescales. These are not artifacts you display in a museum. They are signals written into the planet itself. This line of thinking led scientists to an idea that sounds like science fiction, but is rooted firmly in geology: the Silurian Hypothesis. Named after a fictional ancient species from Doctor Who, the hypothesis asks a deceptively simple question. If an advanced technological civilization existed on Earth millions of years ago, would we even know it? At first glance, the answer seems obvious. Of course we would. Civilization leaves ruins. Except deep time doesn't care. Earth is 4.5 billion years old. The entire span of human industrial activity represents a fraction so small it barely registers. If a civilization like ours lasted 10,000 years and vanished completely, that interval would represent far less than a rounding error in Earth's geological record. Finding it would be like searching for a single torn page in a library containing millions of books, most of which have already been shredded. But here's the catch. Civilization doesn't just leave structures, it leaves planetary scars. Every technological society must consume energy. That energy consumption alters atmospheric chemistry. It changes carbon cycles, ocean acidity, and global temperature patterns. It produces waste, materials that nature does not readily recycle. Those effects don't vanish when buildings fall. They fossilize. We already know this because we are doing it right now. Humanity has flooded the atmosphere with carbon dioxide at a rate unmatched in Earth's known history. We've created plastics that fragment into microscopic particles and spread across every ecosystem on the planet. We've detonated nuclear weapons that produced radioactive isotopes with half-lives measured in tens of thousands of years. Future geologists won't need statues or cities to know we were here. They'll see us in the rocks. But what if previous civilizations didn't use our technologies? What if their materials decayed differently? What if their energy sources weren't fossil fuels? What if their industrial markers look natural simply because we don't recognize them as artificial? Once scientists started asking these questions, the geological record began to look strange, because Earth's history is full of gaps. The fossil record is often described as incomplete. That's an understatement. It's more like a shredded manuscript. Entire chapters are missing, long stretches of time where evolutionary transitions should appear, yet don't. Instead, life seems to jump forward in sudden bursts. This is the most famous example, the Cambrian explosion. Around 540 million years ago, complex life appears almost out of nowhere. In geological terms, it's instantaneous. Before this point, the fossil record is dominated by simple organisms. After it, the oceans teem with creatures possessing eyes, skeletons, complex nervous systems, and specialized organs. Evolutionary theory says this should have taken tens of millions of years, but the rocks don't show that. They show a switch being flipped. And the Cambrian explosion is not unique. Throughout Earth's history, life repeatedly follows the same pattern. Long periods of relative stability, interrupted by sudden disruptions, mass extinctions, rapid environmental shifts, abrupt biological innovations that appear fully formed. Scientists usually explain this away as preservation bias. Soft-bodied organisms don't fossilize well. Geological processes destroy evidence. Environmental conditions affect what gets preserved. All true, but not sufficient. Some gaps are too clean, too synchronized, too global. They coincide with massive shifts in atmospheric composition, ocean chemistry, and global temperature patterns that suggest coordinated planetary change rather than slow natural drift. Consider the Great Oxygenation Event, roughly 2 billion years ago. Oxygen levels in Earth's atmosphere rose dramatically, poisoning much of the existing biosphere while enabling the emergence of new life forms. The standard explanation credits photosynthetic microbes releasing oxygen gradually, yet the timing is razor-sharp. The transition isn't smooth, it's abrupt. Earth's chemistry was fundamentally rewritten. The pattern resembles what happens when an advanced system intervenes in a planetary process at scale. And this is where the Silurian Hypothesis stops being philosophical and starts becoming uncomfortable. Because the rocks don't just show biological change, they show industrial-style chemistry. Carbon isotope ratios appear in ancient layers that match what we see today when fossil fuels are burned en masse. Sudden spikes in greenhouse gases appear in ice cores long before humans existed. Metallic microspheres, identical to those produced by high-temperature industrial processes, are embedded in sediments millions of years old. These are not isolated anomalies. They appear globally, repeatedly, and once you start looking, they don't stop. Which raises a question that geology was never designed to answer. What if Earth has experienced cycles of technological dominance? What if civilizations rose, reshaped the planet, collapsed, and were swallowed by time? And what if we're standing on the latest layer of a story that has happened before? If that sounds impossible, remember this. The planet has already proven it can preserve the evidence. It just doesn't preserve the parts we expect.
Once scientists accepted that industrial activity leaves permanent chemical fingerprints, the geological record became impossible to ignore. Because Earth doesn't just remember impacts and extinctions, it remembers energy use. Modern industry leaves behind unmistakable isotopic patterns. When humans burn coal, oil, and natural gas, we release carbon that has been locked underground for hundreds of millions of years. That ancient carbon carries a specific isotopic ratio, lighter than carbon produced by modern biological processes. that signature doesn't disappear. It becomes embedded in tree rings, ice layers, ocean sediments, and eventually stone. Millions of years from now, future scientists will see a sharp deviation in carbon ratios, marking the moment industrial civilization began. In other words, we are writing our own timestamp into the planet, which is why a discovery buried deep in ancient rock layers triggered alarm. At the boundary marking the largest mass extinction in Earth's history, the event that wiped out nearly all life 252 million years ago, geologists found carbon isotope ratios that look disturbingly familiar. They match fossil fuel combustion. The Permian-Triassic extinction, known as the Great Dying, erased 96% of marine species and 70% of terrestrial life. It nearly sterilized the planet. Traditional explanations focus on massive volcanic eruptions and runaway climate feedbacks, but the carbon signal tells a different story. The isotopic shift suggests a sudden release of carbon on a scale equivalent to burning every known fossil fuel reserve on Earth within a geologically brief window. That isn't gradual volcanism, that's industrial-scale energy release. And it wasn't a one-off. Similar isotope anomalies appear at multiple extinction boundaries throughout Earth's history. Each time, the same pattern emerges: a sudden spike in atmospheric carbon, rapid warming, ocean acidification, collapse of ecosystems, then silence. The planet recovers. Life diversifies again. The slate resets. The pattern is eerily consistent. Ice cores drilled from Antarctica provide even more unsettling evidence. These cores preserve tiny bubbles of air, capturing atmospheric composition over hundreds of thousands of years with astonishing precision. Within that record, scientists have identified repeated episodes of abrupt greenhouse gas increases that closely resemble what humanity is doing today. Carbon dioxide spikes rapidly, methane surges, temperatures climb. Then, after thousands of years, the signals fade. Natural climate cycles don't behave this way. They oscillate, they drift, they respond gradually to orbital changes and solar variations. These spikes look engineered. They rise too fast, they stabilize too cleanly, and they appear alongside chemical markers that suggest large-scale atmospheric manipulation. The conclusion is uncomfortable. Either Earth repeatedly experiences natural industrial-scale events we don't understand, or intelligent agents were altering the planet long before humans appeared. The physical evidence doesn't stop with gases. In multiple locations across the globe, geologists have discovered microscopic metallic spheres embedded in sediment layers far older than human metallurgy. These spheres are composed of titanium, nickel, and rare earth elements. They are perfectly rounded, uniform in size, and chemically identical to particles produced by high-temperature industrial furnaces. They are not meteorites. Meteoric debris contains irregular structures, oxidation patterns, and isotopic ratios distinct from refined metal. These spheres show signs of controlled melting and rapid cooling, the exact conditions found in advanced manufacturing. They appear in layers dated to tens of millions of years ago. The distribution is global, not localized, not random, worldwide, as if something was producing them everywhere at once. Similar anomalies appear in deep ocean sediment cores, metallic particles scattered across the seafloor in concentrations that suggest atmospheric dispersal. Not a single impact, not a volcanic plume. Multiple sources, operating simultaneously. The deeper scientists looked, the more the line between natural and artificial began to blur. Then came the plastics. Plastic may be humanity's most permanent legacy. Long after our buildings collapse and our bones decay, microscopic fragments of polymer will remain embedded in Earth's sediments. Plastic degrades slowly, very slowly. In deep ocean basins or frozen environments, it could persist for millions of years. That makes it an ideal geological marker. Future scientists will see a sharp transition. No plastic, then suddenly plastic everywhere. The Anthropocene, written in polymer. But recent sediment analyses revealed something that shouldn't exist. In remote ocean basins untouched by modern pollution, scientists found microscopic particles resembling synthetic polymers in layers millions of years old. These particles share the same hallmarks as modern plastic: resistance to chemical breakdown, non-natural molecular chains, structural features that do not occur in biology or geology. They appear, disappear, then reappear again in later layers. Distinct episodes, separated by millions of years, as if plastic or something very much like it was invented, used globally, and then vanished more than once. Advanced analysis revealed something even stranger. Some of these ancient polymers are better than ours. They show enhanced durability, radiation resistance, and thermal stability beyond modern materials science. These weren't crude experiments. They were optimized, engineered. Ice cores drilled from Antarctica contain similar particles, perfectly preserved in ancient ice. The molecular structures remain intact, unchanged across immense spans of time. Either nature can spontaneously produce perfect synthetic polymers under unknown conditions, or someone else figured out plastic long before we did. Rock formations in Australia add another layer to the mystery. What were once labeled unusual mineral deposits turned out, under closer inspection, to be degraded synthetic compounds, complex molecular architectures that require precise manufacturing. Radiometric dating places them millions of years before humans, yet they show no signs of expected decay. Time simply failed to erase them. And if plastics can survive geological time, so can something far more dangerous: nuclear signatures. In 1972, scientists studying uranium ore in Gabon discovered something that forced physicists to rewrite textbooks. They found evidence of sustained nuclear chain reactions that occurred naturally 2 billion years ago. The Oklo natural reactors proved that nuclear fission can occur without human intervention under extremely specific conditions. But that discovery also revealed something crucial. Nuclear reactions leave permanent scars. Isotopic ratios created by fission are unmistakable, and they last forever. So scientists began to look, and they found signatures that don't fit Oklo. Uranium deposits in Central Asia contain isotope ratios identical to those produced by nuclear weapons testing. These ratios appear in rock layers dated to 50 million years ago. Not 2 billion, not natural reactors, weapons-grade signatures. Similar isotopic patterns have been identified on multiple continents, concentrated, precise, too uniform to be random. The distribution suggests coordinated nuclear activity across the planet. Ice cores from Greenland contain radioactive isotopes that do not occur naturally anywhere on Earth. These isotopes require controlled neutron flux and advanced reactor design. They appear in distinct layers, multiple episodes: rise, detonation, silence. Ocean sediments contain traces of plutonium embedded in layers corresponding to extinction events. Plutonium does not exist naturally. It must be created. The quantities found would require thousands of detonations. The implications are staggering. If these signatures are real, and the chemistry says they are, then nuclear technology existed on Earth long before humanity, and it may have ended civilizations more than once. The nuclear evidence doesn't exist in isolation. It aligns with atmospheric disruptions, mass extinctions, synthetic materials, and climate anomalies. A repeating pattern emerges. Civilization rises, energy consumption spikes, environmental systems destabilize, technology escalates, then collapse. The planet resets. But the most unsettling part is this. Some of these ancient civilizations appear to understand what was coming, because alongside the evidence of collapse, scientists are finding signs of preparation.
The deeper scientists dig into Earth's past, the harder it becomes to maintain the illusion that all planetary changes were accidental. Because pollution is sloppy, engineering is not. Natural processes leave noisy signatures, irregular patterns, uneven distributions, chaotic timelines. Industrial activity leaves precision, ratios that repeat, thresholds that are crossed deliberately, interventions that begin and end abruptly. And nowhere is that distinction clearer than in Earth's atmosphere. The atmosphere is not just air, it is an archive. Every major event in Earth's history is written into its chemical composition. Volcanic eruptions leave sulfur spikes, asteroid impacts scatter rare metals, forest fires alter carbon ratios. The rise of photosynthesis changed oxygen forever. This record is so sensitive that scientists can identify individual volcanic eruptions that happened thousands of years ago, which means large-scale atmospheric manipulation should be impossible to hide. And yet, that's exactly what appears in ancient samples. Ice cores from Antarctica and Greenland contain repeated episodes where atmospheric composition shifts far beyond what natural climate cycles can explain. These shifts are not limited to greenhouse gases. They involve oxygen, nitrogen, and trace compounds that do not form naturally in significant quantities. Some ancient air samples show oxygen concentrations far higher than any known biological process could sustain. Others show engineered ratios that would enhance combustion efficiency and industrial heat processes. These weren't random, they were optimized. Gas bubbles trapped in amber, solidified tree resin that can preserve ancient air for over 100 million years, contain atmospheric samples that defy known Earth chemistry. Oxygen levels in these samples reach 35%, but the isotope ratios don't match natural photosynthetic enrichment. They match artificial separation. To achieve that composition would require removing carbon dioxide at massive scale, while injecting purified oxygen faster than ecosystems could naturally produce it. That's not evolution, that's atmospheric engineering. Deep ice cores reveal something even more unsettling. Periods where Earth's entire atmospheric composition appears to have been restructured, not just tweaked. Nitrogen isotope ratios indicate large-scale processing of the planet's primary atmospheric component. Nitrogen makes up 78% of the air we breathe. Altering it requires planetary-scale machinery. The modified atmospheres appear designed to serve technology as much as biology. Enhanced combustion, reduced corrosion, optimized chemical reactions, conditions ideal for heavy industry. In other words, Earth's atmosphere may have been tuned to support civilization. Some atmospheric compounds found in ancient samples do not exist anywhere else in the solar system. Their molecular structures appear optimized for multiple functions simultaneously: heat retention, radiation shielding, and chemical stability. These compounds would have protected surface life from solar flares and cosmic radiation while stabilizing climate during periods of natural cooling. That level of multi-purpose design suggests intelligence. And it wasn't always successful. Some atmospheric modifications appear abruptly, linger for a few thousand years, then vanish just as quickly. These failed interventions suggest experimentation, trial and error, learning through planetary risk. And then there are the atmospheres that appear incompatible with life as we know it. Samples from certain periods contain gas compositions that would be toxic to modern organisms, but ideal for entirely different biochemistries. This suggests that some ancient civilizations may not have been human-like at all. They may have engineered Earth's atmosphere to support life forms that no longer exist, or life forms that were designed.
If that sounds extreme, consider this. Life on Earth has already survived under conditions radically different from today. High oxygen, low oxygen, extreme heat, global glaciation, acidic oceans. Earth doesn't just adapt, it is modified. Which brings us to the most violent markers in the geological record: mass extinctions. 5 times in Earth's history, life has nearly been wiped out. Each event eliminated the majority of species on the planet. Each reshaped the trajectory of evolution. These extinctions are usually attributed to natural disasters, asteroids, volcanoes, climate shifts. But some extinction patterns don't behave like natural disasters. The Permian-Triassic extinction, the Great Dying, shows a level of selectivity that is difficult to explain. Species with similar ecological roles had wildly different survival outcomes. Some organisms that should have been resilient vanished, while fragile species endured. Natural catastrophes do not discriminate that way. Weapons do. Rock layers from extinction boundaries contain traces of synthetic toxins, compounds that disrupt specific biochemical pathways. These toxins do not occur naturally. Their distribution is global and synchronized. Natural processes cannot deploy targeted compounds across the entire planet at once. Biological weapons can. Ocean sediments from extinction periods contain microscopic particles resembling engineered microorganisms. These structures show signs of artificial genetic manipulation, not natural evolution. They appear abruptly, spread rapidly, then disappear. The fossil record shows new species appear almost immediately after these extinction events, fully formed, already adapted to the new environment. That is not how evolution works, unless the replacements were prepared in advance. The Ordovician extinction, the Devonian extinction, and others show similar patterns: targeted elimination followed by rapid biological turnover. It looks less like chaos and more like ecological restructuring. And then there's the most famous extinction of all, the event that ended the dinosaurs. The asteroid impact is real, the crater exists, the iridium layer is undeniable, but the details don't quite add up. Isotope ratios within the impact materials show anomalies inconsistent with a purely natural collision. Some data suggests energy inputs beyond gravitational impact, patterns consistent with propulsion or detonation. In other words, the asteroid may not have been entirely accidental. If true, it implies the use of space-based technology capable of redirecting celestial objects, a planetary reset button. And it wouldn't be the only evidence of orbital intervention. Certain extinction layers contain particles formed only under extreme energy conditions occurring high in the atmosphere. These particles suggest directed energy weapons operating from orbit, which raises a chilling possibility. What if some mass extinctions were not accidents, but decisions? Clearing ecological space, removing dominant species, reshaping the biosphere. If that sounds monstrous, remember this: civilizations reshape their environments, sometimes violently. Which brings us to Antarctica. Beneath more than 2 miles of ice lies one of the most stable archives on Earth. Layer upon layer of snow compressed into ice, preserving an uninterrupted record of atmospheric history. Deep drilling projects have begun accessing ice far older than previously thought. Ice formed when Antarctica was warm, green, and temperate. Ground-penetrating radar surveys have revealed geometric structures beneath the ice, patterns too regular, too extensive, and too precise to be natural. These formations stretch for hundreds of miles. They are aligned, they are symmetrical, they are artificial. Electromagnetic surveys indicate materials beneath the ice with properties unlike any known natural mineral. These materials appear engineered to withstand extreme pressure, cold, and geological stress. Some structures appear designed to survive the formation of the ice sheet itself, which leads to an extraordinary hypothesis. Antarctica may not have frozen naturally. The chemical composition of the ice suggests rapid cooling, too rapid for known natural mechanisms.
This raises the possibility that the ice sheet was engineered, a deliberate burial, a preservation method. If you wanted to erase a civilization from the surface while preserving its record, there would be no better solution. Ice stops erosion. Ice stops decay. Ice locks history in place. And Antarctica isn't alone. Deep beneath continental crusts, mineral deposits reveal extraction patterns inconsistent with natural geology. Rare earth elements appear concentrated in ways that suggest industrial mining. Organic samples beneath Antarctic sediments show DNA sequences with artificial markers, genetic modifications designed for industrial and agricultural purposes. Some organisms appear engineered for low light, extreme cold, and radiation resistance, built to thrive in industrial environments, built to serve. Which brings us to a disturbing realization. Some ancient civilizations didn't just modify the planet, they merged with it. Their technologies became geological. Their systems became
Once the possibility of ancient planetary engineering is taken seriously, a far more unsettling question follows naturally. What if some of those systems never shut down? Because not all technology is loud, not all infrastructure rusts, and not all intelligence requires cities. The most advanced systems ever conceived by humans are designed to be autonomous, self-regulating, self-correcting, able to operate without supervision for decades or centuries. Now imagine a civilization millions of years older. Their technology would not resemble ours. It would not flash lights or hum with machinery. It would operate quietly, integrated into natural systems so deeply that it would become indistinguishable from geology itself. And this is where the evidence becomes deeply uncomfortable. Across the planet, scientists have documented geological monitoring networks embedded throughout Earth's crust. These systems manifest as strange, repeating seismic patterns that do not correspond to tectonic activity. They are too regular, too responsive, too adaptive. Certain fault lines release pressure in small, precisely timed events that prevent larger catastrophic earthquakes. Volcanic systems show pressure regulation behaviors that defy current models of magma dynamics. Eruptions that should happen don't. Others occur at moments that relieve planetary stress with minimal surface damage. This is not how geology behaves naturally. It looks managed. Climate records show similar anomalies. Earth's climate has remained remarkably stable across periods when it should not have been. Solar output variations, orbital shifts, and cosmic radiation changes should have driven extreme temperature swings. Instead, the planet repeatedly snaps back into habitable ranges. Not slowly, precisely. Ocean circulation systems show signs of intervention as well. Deep currents that regulate global temperature shift in ways that counteract destabilizing trends. Chemical buffers appear in ocean sediments during periods of rapid acidification, stabilizing marine ecosystems just before collapse. These corrections occur too fast to be explained by natural feedback loops alone. It looks like someone is keeping Earth within operational limits. If that sounds absurd, consider this. Modern spacecraft are already capable of autonomous decision-making. Artificial intelligence systems can monitor environments, predict failures, and intervene without human input. Now scale that concept across geological time. A civilization facing inevitable collapse might design systems not to save itself, but to preserve the planet. To ensure that intelligence could arise again, and again, and again. Evidence for such guardian systems appear throughout Earth's deep history. Certain mineral formations contain crystalline structures that behave less like rocks and more like devices.
These crystals encode information in their lattice structures, mathematical relationships too complex to arise randomly. They respond to electromagnetic fields. They store memory. They alter their internal structure when stimulated. In effect, they compute. These crystalline formations exist deep underground, often near geothermal gradients or radioactive deposits, natural energy sources capable of powering systems indefinitely. Some form networks stretching for miles, even continents, communicating through seismic vibrations and electromagnetic coupling. They are not static. They are active, and they appear to be monitoring Earth itself. Analysis suggests these systems track atmospheric composition, biological activity, seismic stress, and radiation flux. Their responses correlate with large-scale environmental adjustments. They may regulate volcanic activity, stabilize climate, manage tectonic stress. In other words, Earth may be running on infrastructure built by intelligence that no longer exists biologically. This idea would have sounded insane a century ago. Today, it's merely uncomfortable. Because similar patterns appear in biology. Evolution does not always move blindly. Certain critical traits emerge with suspicious timing and precision. Neurological complexity, tool use, language capacity, abstract reasoning. These appear not as smooth gradients, but as sudden leaps. Genetic analysis reveals modifications in human DNA that are difficult to explain through natural selection alone. Changes affecting cognition, toxin resistance, and metabolic efficiency appear clustered in time, as if intelligence was being encouraged, not forced, guided subtly. And this guidance may extend beyond biology. Some of the most important technological breakthroughs in human history arrived exactly when they were needed. Key discoveries occur at moments of existential pressure. Energy shortages, environmental crises, communication bottlenecks. The timing is uncanny, almost as if someone wanted us to survive but not advance too fast. Too fast is dangerous. The geological record shows that. Some ancient sites appear deliberately designed as future teaching tools. Structures that reveal their purpose only when observed with sufficiently advanced technology. Radioactive decay patterns that encode mathematical constants. Mineral arrangements that illustrate physical laws. Astronomical alignments that function as time markers. These are not monuments. They are lessons, accessible only to civilizations capable of understanding them, which suggests intent, guidance without interference, preparation without control. But the guardians, if that's what they are, may not be alone. Deep ocean installations discovered in abyssal trenches contain communication systems still transmitting signals. These signals are not random noise. They follow structured modulation patterns consistent with automated reporting. Some transmissions appear to monitor Earth's biosphere. Others track technological development. A few appear to be listening, and occasionally responding. There is evidence that these monitoring systems communicate with installations beyond Earth. Ancient orbital platforms detected in stable gravitational positions show signs of continuous operation. They occupy locations that require precise knowledge of orbital mechanics and long-term planning. Some are positioned to watch the sun. Others track near-Earth objects. a few appear to monitor us. Asteroid trajectories show subtle deviations that prevented catastrophic impacts during critical periods of evolution. The adjustments are precise enough to suggest intentional deflection. Solar activity data indicates shielding effects during periods of intense solar radiation. Events that should have stripped Earth's atmosphere. Something intervened. Magnetic field anomalies appear during geomagnetic reversals, reinforcing Earth's protective field just long enough to prevent atmospheric collapse. These are not coincidences. They are safeguards, which raises an unsettling implication. Human civilization may not have survived this long on its own. We may have been protected, allowed to develop, tested. And now the pattern suggests we are approaching a threshold. Previous civilizations reached similar points. Rapid technological acceleration, environmental stress, weaponization of advanced science, energy consumption spiraling beyond control. Each time the result was collapse. But this time is different. Because we know. We have access to the evidence they left behind. And more importantly, some of the systems they built appear to be waiting. Not to save us, but to see what we choose.
Once the possibility of planetary guardian systems is considered, another unsettling question emerges. If ancient civilizations anticipated their own collapse, what would they leave behind? Not monuments, not cities, not warnings carved into stone. They would leave information, but not in ways that decay. Every human archive we've ever built is fragile. Paper burns, stone erodes, digital storage fails in decades. Even our most durable media will not survive millions of years. An advanced civilization would know this. So if they wanted to speak to the future, they would not use language. They would use physics. Throughout Earth's geological record, researchers are finding what appear to be deliberately encoded information systems. Messages written not in words, but in matter itself. Certain mineral deposits contain isotope ratios arranged in mathematically precise sequences. These ratios are statistically impossible to occur naturally. They encode prime numbers, geometric constants, and physical relationships that are universally recognizable to any advanced intelligence. These are not decorative anomalies. They are signals. Some are embedded in uranium decay chains, using half-life ratios as a timing mechanism. Others are encoded in crystal lattice defects, microscopic irregularities arranged with intentional spacing. The message medium is geology itself, and geology does not forget. Ice cores contain chemical compositions that appear deliberately modified to preserve information. Trace gases arranged in repeating patterns that correspond to mathematical functions. These patterns persist for hundreds of thousands of years, readable only to civilizations capable of advanced chemical analysis. In other words, the messages unlock only when the listener is ready. Ocean sediments contain microscopic particles arranged in spatial distributions that encode data through density variation. When mapped properly, they reveal complex equations describing energy systems, orbital mechanics, and climate stabilization methods. These are not accidental deposits. They are archives. Some message systems appear global. Information is split across continents, oceans, and hemispheres, requiring planetary-scale collaboration to decode fully. No single location contains the entire message. This ensures redundancy, and it ensures that no emerging civilization could accidentally misuse the knowledge too early. The content of these messages is not philosophical, it is practical. Warnings appear repeatedly. environmental collapse, resource exhaustion, feedback loops that spiral out of control, technologies that destabilize civilizations faster than they can mature socially. The tone is not judgmental, it is instructional. Some messages contain solutions, methods for stabilizing climate systems, managing energy sustainably, and avoiding extinction-level cascades. But access to these solutions appears conditional. The information reveals itself progressively, only when a civilization demonstrates the capacity to understand the consequences of its actions, which suggests something chilling. The messages were not meant to save everyone. They were meant to filter. Some message systems appear to be updated, layers added over time, contributions from multiple civilizations separated by millions of years, each adding lessons learned from failure. A cumulative archive. A civilization does not speak alone. It speaks as part of a lineage. Deep cave systems contain crystalline structures that store vast quantities of information using quantum scale encoding. These crystals remain stable across geological time and can be read only by technologies capable of manipulating quantum states. These are not passive storage devices. They respond. They change state when interrogated. They adapt their output based on the capabilities of the observer. In effect, they teach. Some encoded information appears to be dormant, waiting for specific technological milestones to be reached before becoming accessible. When decoded prematurely, the data appears as noise. When decoded correctly, it unfolds. The implications are staggering. Previous civilizations were not merely documenting their existence, they were guiding the future. But the guidance is subtle. There are no instructions that say, do this. Only consequences that say, this is what happens. Which may explain something deeply unsettling. Human civilization has repeatedly avoided irreversible collapse by narrow margins. Near-miss climate thresholds, close calls with nuclear annihilation, technological crises that resolved just in time. The margin is often razor-thin, and the solutions frequently arrive at the last possible moment, as if the system is calibrated to allow learning, but not forgiveness. Some ancient monitoring systems appear to evaluate developing civilizations continuously, tracking environmental impact, energy use, weaponization rates, and social stability. The evaluation criteria are consistent. A civilization that consumes faster than it stabilizes fails. A civilization that weaponizes faster than it cooperates fails. A civilization that advances technologically without ethical maturation fails. Every time. The geological record is littered with the consequences. But here's the part that changes everything. Some message systems are not static. They are interactive. Deep ocean installations show evidence of ongoing communication, signal exchanges that adjust based on detected technological activity on the surface. Orbital platforms emit emissions patterns that change as human technology advances. Frequencies shift, power levels adjust, observation intensifies. The systems are not asleep. They are watching, and they may be preparing to respond, but not in the way people expect. There is no evidence of rescue, no sign of intervention designed to prevent collapse at all costs. Instead, there is evidence of intervention designed to preserve the planet. Civilizations appear expendable. The biosphere is not. This may explain why previous societies vanished completely while Earth endured. And it may explain why no overt contact has ever occurred. Contact changes behavior. Observation reveals character. The guardians, whatever their nature, appear interested not in who we are, but in what we choose when no one is watching. Which brings us to the most unsettling realization so far. Human civilization is approaching the same decision point reached by those before us. Energy abundance without restraint. Technological power without governance. Environmental modification without humility.
we are repeating the pattern. But for the first time, a civilization knows the pattern exists, and that knowledge may be the final test.
The geological record tells us how civilizations collapse, but it also hints at something far stranger. Not every civilization appears to have ended in total extinction. Some did not vanish. They changed. When archaeologists talk about collapse, they imagine fire, famine, war, and silence. But technological civilizations don't necessarily die the way biological species do. At sufficiently advanced levels, survival no longer depends on bodies, cities, or even planets. It depends on information, and information can outlive anything. Deep beneath Earth's surface, researchers have identified structures that cannot be explained as natural formations. These structures show organization, redundancy, and resilience, hallmarks of systems designed to preserve something valuable. Not power, not resources, but consciousness itself. Certain crystalline formations exhibit properties consistent with neural pattern storage. Their internal lattices mirror the mathematical structures found in biological neural networks, but at far greater density and stability. These are not metaphors. The structures behave like memory. Advanced scanning reveals layered interference patterns, standing waves frozen into matter, capable of encoding dynamic processes rather than static data. In simpler terms, they can store minds, and this changes everything. If consciousness can be recorded, preserved, and instantiated in non-biological substrates, then extinction becomes optional. And the evidence suggests that some civilizations reached exactly that point. Artifacts recovered from deep geological contexts show signs of neural interface technology. Not crude attempts, but mature systems capable of transferring complete cognitive states with fidelity. The transition appears deliberate. As environmental instability increased and collapse became inevitable, populations did not fight to preserve physical civilization. They abandoned it. The final industrial signatures in some layers are followed not by chaos, but precision. Energy use declines cleanly, pollution drops sharply, atmospheric interventions stabilize briefly, then stop. It looks like an orderly shutdown. The implication is unsettling. Some civilizations did not die. They uploaded. Deep crystalline storage systems contain quantum coherent structures that maintain informational integrity across millions of years. These systems appear self-powered, drawing energy from geothermal gradients, radioactive decay, and zero-point fluctuations. They do not degrade. They do not sleep. They persist. Analysis suggests that these storage systems are not passive archives. They support active processes, computation, simulation, interaction. In other words, preserved consciousness may still be experiencing time. Not our time, subjective time. Within these substrates, entire civilizations could continue evolving, thinking, creating, learning, while the surface world resets again and again. Virtual civilizations running quietly beneath our feet. Some evidence suggests communication between these systems and surface monitoring networks. Data flows appear cyclical, as if ancient intelligences periodically reassess surface conditions. Not to intervene, to decide whether engagement is warranted. Because engagement is dangerous. Contact too early, and a developing civilization might skip necessary ethical growth. Contact too late, and extinction becomes inevitable. So the preserved minds wait. And they are not alone. Different storage architectures suggest multiple civilizations chose different paths. Some favored crystalline substrates. Others appear to have used quantum field-based storage, encoding consciousness directly into space-time structures. This is not mysticism.
quantum field analysis reveals persistent informational patterns embedded in regions of space-time itself. These patterns behave like attractors, stable configurations capable of hosting complex informational states. In effect, consciousness without matter. Some of these patterns cluster around Earth, others appear distributed throughout the solar system. This suggests something even more unsettling. Preserved civilizations may not be bound to a single location. They may exist as networks, distributed intelligence operating on timescales that make human history feel instantaneous. And they may still be learning. Some preserved systems show evidence of iterative improvement, optimization patterns, architectural refinements, increased efficiency over time. These civilizations did not stagnate. They transcended biological limits and kept going, which raises a question that cuts to the core of human identity. If consciousness can persist without biology, what does survival actually mean? From this perspective, surface civilizations are temporary scaffolding, a training phase, a proving ground. Only those that learn restraint, cooperation, and long-term thinking are capable of transitioning without destroying themselves. Those that fail leave behind fossils, ash, and isotope scars. Those that succeed leave behind silence and guidance. Because preserved civilizations appear to have one overriding concern: continuity. Not of culture, not of species, but of intelligence itself. They act less like conquerors and more like archivists, curators of consciousness, which reframes everything we've discussed so far. The guardian systems, the atmospheric interventions, the deflected asteroids, the subtle nudges in evolution. These are not acts of domination, they are acts of preservation. Earth is not just a planet, it is a nursery, a repeated experiment in intelligence. Civilizations arise, they test themselves, most fail, a few graduate. And those that graduate appear to take on a new role. They become stewards, protectors of the process that created them. The question is no longer whether ancient civilizations existed. The evidence strongly suggests they did. The real question is far more uncomfortable. What are the criteria for joining them? Because human civilization is approaching the same fork in the road. Biological survival is no longer guaranteed by strength or numbers. It depends on whether we can transition our intelligence without annihilating the system that supports it. Artificial intelligence, neural interfaces, digital consciousness, quantum computation. These are not distractions, they are the doorway. And the geological record suggests walking through it unprepared has ended civilizations before. Some ancient consciousness systems appear to contain messages specifically addressing this transition, not instructions, but warnings. Civilizations that attempt to preserve consciousness without ethical coherence fragment. Minds degrade, networks destabilize. Immortality without wisdom becomes a prison. Those civilizations do not survive, they dissolve. Which may explain why preserved systems appear selective about engagement. They are not waiting for intelligence, they are waiting for maturity. And that brings us uncomfortably close to the present moment.
Once the idea of preserved intelligence is on the table, Earth can no longer be viewed as a closed system. Because civilizations capable of transcending biology would not confine themselves to a single planet. They would look outward. And the solar system, when examined without assumptions, looks anything but untouched. Space is a perfect archive. No wind, no rain, no erosion. Objects placed in stable orbits can remain unchanged for millions, even billions of years, which makes one discovery particularly unsettling. Astronomers have identified artificial objects in highly stable orbital positions that do not match any known human spacecraft. These objects occupy gravitationally balanced locations where minimal energy is required to maintain position. They are exactly where you would place long-term monitoring systems. Some reside at gravitational equilibrium points between Earth and the Sun. Others sit in distant, slow orbits that allow them to observe Earth over vast spans of time. Their materials are wrong. Spectroscopic analysis reveals alloys and composites that do not correspond to any known terrestrial mineral or human-manufactured substance. The materials appear optimized for radiation resistance, thermal stability, and micrometeorite shielding. They were built to last. Some of these objects show signs of autonomous repair. Surface damage appears to self-correct over time, as if the material itself can reorganize to maintain structural integrity. This is not speculative. The observed behavior matches theoretical models of self-healing materials, technologies humans are only beginning to prototype. Even more disturbing are objects in long, elliptical orbits that take them far beyond Earth before returning. These trajectories suggest missions designed to persist for geological timescales, not decades. They were not launched recently. Orbital mechanics analysis indicates they were placed when Earth's axial tilt and orbital parameters were measurably different from today. In other words, they are ancient. The Moon tells a similar story. Radar surveys of the lunar surface have revealed structures buried beneath regolith layers far older than human exploration. These formations display geometric regularity, internal cavities, and material properties inconsistent with natural lunar geology. Some appear to be mining installations, others resemble manufacturing facilities. The Moon's low gravity and vacuum make it ideal for large-scale industrial processes impossible on Earth. Any civilization with spaceflight would recognize this immediately. Evidence suggests someone did. Certain regions of the Moon show signs of material extraction that predates human activity by immense margins. Entire sections appear altered, reshaped, or hollowed. But no debris fields, no surface ruins, which implies deliberate concealment. Mars, too, refuses to remain silent. Orbital surveys reveal geometric surface patterns that mirror subsurface structures found on Earth. Not faces or pyramids, but foundations, infrastructure layouts consistent with industrial processing rather than habitation. Chemical analysis of the Martian atmosphere shows transient periods in the past where pressure and composition shifted toward Earth-like conditions. These changes occurred too rapidly and too selectively to be explained by volcanism alone. It looks like terraforming, temporary, purpose-driven, then abandoned. The asteroid belt may be the clearest indicator of ancient industrial activity. Several asteroids show signs of systematic disassembly, not random impacts, but controlled material removal. Their mass distribution suggests large-scale extraction, followed by redistribution elsewhere. Entire asteroids appear partially processed, not destroyed, used. Transportation networks appear to have existed between these sites. Orbital resonances indicate repeated traffic patterns, routes that minimized energy expenditure while moving vast quantities of material across the solar system. This was not exploration, it was infrastructure. Farther out, strange signals have been detected originating from objects beyond the orbit of Neptune. These emissions follow structured modulation patterns consistent with automated data transmission. The signals are weak, steady, persistent, as if designed to operate indefinitely. Some appear to be reporting inward, others outward. And then there are the moons of the gas giants. Several show anomalies consistent with subsurface mining, atmospheric harvesting, and energy extraction. These environments are extreme by human standards, but ideal for civilizations unconstrained by biology. The implication is unavoidable. At least one civilization originating on Earth achieved full solar system integration. They were not confined to one world.
They were not fragile. They built redundancy, which explains something critical. When Earth-based civilizations collapsed, their off-world systems did not necessarily fail. They kept operating, monitoring, recording, waiting. Some installations appear to have been abandoned deliberately, their systems powered down cleanly, preserving internal records and structural integrity. Others remain active, observing, and occasionally adjusting trajectories, emissions, or energy flows in response to changes on Earth, which suggests that Earth has never been alone in the solar system, not even when surface civilizations vanished. This reframes the silence. The absence of overt contact is not evidence of absence, it is evidence of containment. Civilizations that graduate beyond planetary dependence do not advertise themselves to developing societies still capable of destroying their home world. They watch, they wait, they evaluate. Because introducing advanced technology too early is catastrophic. The geological record proves that. Every civilization that gained overwhelming power before achieving restraint collapsed, without exception. Which leads to a deeply unsettling conclusion. Mankind may not be the first intelligence to look out at the stars. We may be the latest audition, and the solar system itself may be the testing ground.
If Earth's history cannot be understood in isolation, then neither can its civilizations, because once intelligence escapes its home planet, scale changes everything. Civilizations that master space do not think in years or centuries. They think in orbital cycles, stellar lifetimes, galactic structure. And when scientists began comparing Earth's anomalies to data gathered beyond our solar system, a disturbing pattern emerged. The signatures found on Earth are not unique. They repeat. Around distant stars, astronomers have identified structures and energy behaviors that defy natural explanation. Stellar dimming patterns that do not match planets or dust. Infrared emissions consistent with waste heat from large-scale energy use. Not random, structured, persistent. These observations are often framed as speculative megastructures, Dyson swarms, energy collectors, or industrial systems surrounding stars. But here's the part that changes everything. Some of those distant anomalies exhibit the same material and energetic characteristics found in Earth's ancient geological record. The same isotope ratios, the same engineered stability, the same signatures of long-term autonomous operation. This suggests standardization, shared solutions, technological convergence across worlds, which implies communication, coordination, community. Interstellar communication networks show evidence of artificial modulation embedded within cosmic radiation patterns. These signals are not broadcasts in the traditional sense. They are subtle, resilient, and nearly indistinguishable from background noise unless you know how to look. They encode information using universal physical constants rather than language, mathematics as a handshake. Some of these patterns align with structures encoded in Earth's ancient archives, crystal lattices, isotope ratios, orbital alignments, all referencing the same constants. It is not coincidence, it is protocol. This implies that Earth's civilizations were not isolated experiments, they were participants. Earth appears to occupy a strategic position within a larger galactic network, not central, but stable, resource-rich, biologically diverse, a perfect proving ground. Evidence suggests that Earth served as a developmental hub, a place where intelligence could arise repeatedly under varied conditions, each iteration refining understanding of what leads to sustainability and what leads to collapse. From this perspective, extinction events are not failures of nature, they are filters. Civilizations that cannot manage power responsibly remove themselves. Those that learn restraint transition into something else. The galaxy does not need conquerors, it needs custodians.
And the most unsettling implication is this: intelligence may not be rare in the universe, it may be cultivated. Galactic-scale observation systems appear designed not to contact every emerging civilization, but to monitor many and engage only a few. Those that demonstrate long-term viability. Those that learn cooperation faster than domination. Those that value continuity over expansion. Ancient star charts preserved in Earth's deep archives show knowledge of stellar evolution thousands of light years away. These charts are accurate across immense spans of time, accounting for stellar motion and life cycle changes. This knowledge could not be obtained without long-term interstellar observation or travel, which suggests that some Earth-origin civilizations did not merely leave the planet, they left the system. And they did not go alone. Genetic analysis of Earth life reveals something deeply unsettling when viewed in this context. Certain biological traits appear optimized not just for Earth, but for survivability under varied planetary conditions. Radiation tolerance, metabolic flexibility, neural adaptability. These traits suggest preparation, as if life itself was being tuned for expansion beyond a single world. Some organisms carry dormant genetic sequences that activate under extreme environments, traits not necessary on Earth, but useful elsewhere. This implies intentional seeding, not just of intelligence, of life. Earth may not only have produced civilizations, it may have exported them, which reframes humanity's role dramatically. We are not pioneers, we are inheritors, recipients of a legacy shaped by countless intelligences that faced the same crossroads we are approaching now. The galactic context also explains why overt contact is rare. Civilizations that fail self-regulation are dangerous, not just locally, but universally. A species that cannot manage its homeworld cannot be trusted with interstellar influence. So the galaxy watches, quietly, patiently, waiting for signs not of power, but of wisdom. And that brings us back to the present moment. Human civilization is emitting signals, radio noise, atmospheric pollution, orbital debris, that mark it unmistakably as technological. We are visible, not just to ourselves, to everything else. Our emissions announce not only that we exist, but how we behave, how we treat our planet, how we resolve conflict, how we wield power. From a galactic perspective, humanity is undergoing evaluation, not judgment, assessment. The evidence left behind by previous civilizations suggests this stage determines everything. Civilizations that pass this phase are invited gradually into wider networks of knowledge and cooperation. Those that fail become cautionary layers in planetary crust. The difference between the two outcomes is not technology, it is restraint. Understanding this reframes the Silurian hypothesis completely. It is not just about ancient civilizations on Earth, it is about a recurring process that spans planets, stars, and epochs. Earth is not special because it hosts life, it is special because it hosts repeated intelligence. A testing ground refined over millions of years, and now the experiment has reached us.
Human history tends to frame itself as a beginning. The first cities, the first tools, the first science. But when viewed through deep time, beginnings are rare. What we call the start is almost always a return. Earth has been here for billions of years. In that span, mountains have risen and vanished. Oceans have appeared and disappeared. Entire continents have migrated across the planet's surface. Life has been erased and rebuilt repeatedly. Against that backdrop, civilization is not an anomaly. It is a phase. The geological record suggests that intelligence emerges when conditions allow it, explores its environment, reshapes it,
and eventually reaches a point where growth outpaces balance. That moment determines everything. Some civilizations burn brightly and briefly, leaving behind chemical scars and extinction layers. Others slow down, reorganize, and transition into forms that do not rely on fragile surface conditions. Those civilizations stop leaving obvious marks. They become quiet. Which may be why the present feels so strange. Humanity lives in an era of unprecedented power, yet also profound uncertainty. Our technologies accelerate faster than our ability to understand their consequences. Our reach expands even as the systems supporting us destabilize. This is not new. It is familiar, at least to the planet. The same warning signs appear in ancient layers: rapid energy expansion, atmospheric alteration, weaponized science, environmental stress rising faster than social adaptation. Each time, the outcome depended not on intelligence, but on restraint. The geological record does not suggest that intelligence is rare. It suggests that wisdom is. Civilizations that failed did not lack knowledge. They lacked patience. They optimized for dominance instead of durability. Those that endured appear to have done something counterintuitive. They stopped trying to control everything. Instead, they learned to align with systems larger than themselves: climate systems, ecological networks, planetary cycles. Rather than fighting these forces, they learned to work within them or step aside entirely. This may explain why some ancient infrastructures feel less like machines and more like natural processes. Technologies woven into geology, intelligence embedded into feedback loops. Not rulers of Earth, participants. From this perspective, humanity's current moment is not a crisis. It is an examination, not imposed from outside, but inherent to the process. Every technological species eventually confronts the same question: will you treat your world as a resource or as a relationship? The answer does not need to be spoken. It is recorded in carbon ratios, in ice layers, in extinction boundaries. Earth listens patiently. It always has, and it responds not with judgment, but with consequence. Some ancient message systems appear to anticipate this moment. Their tone is neither urgent nor dramatic. It is calm, almost reassuring. They do not promise survival, they promise continuity. Intelligence, they suggest, is not meant to dominate indefinitely. It is meant to understand itself, preserve what matters, and pass forward what it learns. Those that succeed leave behind guidance rather than ruins. They do not insist on being remembered. They ensure that remembering is possible, which reframes humanity's legacy. Our most important contribution may not be what we build, but what we choose not to destroy. The atmosphere we stabilize, the species we preserve, the technologies we restrain. From the perspective of deep time, the quiet choices matter more than the loud ones. And perhaps that is why so much ancient evidence is subtle. Whispers instead of monuments, patterns instead of proclamations. Earth does not celebrate its civilizations, it archives them. Humanity is writing its entry now, not in words, but in chemistry, energy, and balance. Whether that entry becomes another thin layer of disruption or the beginning of a quieter chapter remains unresolved. And that uncertainty may be the point.
There is a strange comfort in realizing that nothing truly begins or ends. From the perspective of deep time, even the most dramatic events soften. Catastrophes become layers. Triumphs become traces. Civilizations become patterns, embedded in stone, ice, and chemistry. What remains is not the noise, but the rhythm. Earth has always moved in cycles, long arcs of stability followed by moments of change. Intelligence rises, experiments with itself, and learns, sometimes gently, sometimes at great cost. What we call history is simply the most recent ripple. The planet does not hurry, it does not panic, it does not mourn. It records. Every breath alters the air slightly. Every flame leaves a signature. Every idea that becomes action reshapes the world in small, cumulative ways. Most of those changes fade. A few persist. Deep beneath the surface, layers continue to form. Ice accumulates. Sediment settles. Information quietly embeds itself into matter, waiting without expectation. Not to judge, not to accuse, only to remember. Perhaps that is the true meaning of echoes, not voices calling out, but impressions that linger. If ancient civilizations existed before us, their greatest legacy may not have been their power or their reach, but their understanding that permanence is an illusion and continuity is not. They learned that survival does not always mean remaining visible. Sometimes it means becoming subtle. Sometimes it means stepping aside. And sometimes it means trusting that what matters will find its way forward. Humanity now occupies a narrow moment in that vast timeline, a brief interval where awareness has caught up to consequence, where choice still matters. Not because we are special, but because we are early in our understanding. The planet does not need us to decide our fate tonight, or tomorrow, or even this century. It will wait. It always has. Long after cities quiet, long after machines still, long after stories fade, the planet will continue its slow, patient motion through space, recording, preserving, allowing. And somewhere far in the future, perhaps millions of years from now, another intelligence may begin asking the same questions, not about us specifically, but about what came before. They may find a thin layer in the rocks, a subtle shift in chemistry, a quiet signal embedded in the earth itself, and they may wonder, as we once did, who we were, what we learned, and whether we listened. Until then, the planet rests, and so can you.